Hey math students, you're on page 339. Two people describe a regular polygon. That is important information because a regular polygon means it's some type of shape, we don't know how many sides, where all sides are equal, the same. Could be a square, could be a triangle with 3 equal sides, could be a hexagon, a pentagon, octagon, we don't know, right? But that word regular means all sides are the same. Brown says the polygon has a side length of 6.3 centimeters and a perimeter of 31.5 centimeters. So, okay, that means each side in her shape is 6.3 centimeters long. And then if you add them all together, the distance around the outside is 31.5 centimeters. Desiderio says the polygon has a side length of n and a perimeter of 5n. So interesting, her shape, the side length is n, and if you add them all together, you get a perimeter of 5n. Which person's description tells you how many sides the polygon has? Oh, well, that would obviously be Desiderio, because she gave us the expression 5n, n being the side length, and there are 5 sides. So a shape with 5 sides would be like a pentagon. So this is my best attempt at a pentagon, where all the sides are n and equal. If I were to add this all up, n plus n plus n plus n plus n would equal 5n, just like Desiderio said, and we got 5 sides. We're on to the next one. A company sells rectangular pools. The length of each pool is 2 times the width. So let's draw out what that actually means. So we've got a rectangular pool. Doesn't have to be perfect, but there's your rectangle. And the length of the pool is 2 times the width. So here's the width, and if this is the length, this is 2w. We know about rectangles, there's a w here and a 2w there. Jelani represents the perimeter of a pool. Customer is 6w. Perimeter is just adding all the sides, right? 2w plus w plus 2w plus w. Remember, w's by themselves would have 1, and you get 6w. That makes sense. Akiko represents the perimeter of the pool as the expression of 2 times 2w plus w. Well, if we distribute that out, we get 4w plus 2w, which still gives us 6w. So they're saying the same thing, but explain what information each expression tells a customer. Well, Jelani, that's going to be the total perimeter. Right? All she did was say, hey, this is going to be 6w, whereas Akiko, she's going to say, hey, here is the cost of what the length is, plus what the cost of the width is, which again tells the customer the same information in the end, because it still gives us 6w, but is a little bit more specific by saying, yeah, your length is going to cost this much, your width is going to cost this much. Your club is sewing school flags for the pep rally. The club members want to find the amount of striped fabric that they need for one flag. So only these areas, right? The Go Panther and the Purple Panther Power, because those are striped fabric. Avery says they can use the expression 5 times 4. She's talking about these 2 dimensions. And 7 times 4, she's talking about this dimension right here. Notice the 7 came from the bottom right there. The 4 comes from the side right here. If you add those together, you'll get how much they need. Pedro says, hey, we can just do 12 times 8, meaning we can do everything on the bottom, 12, everything on the side, 8, and then divide by 2, because basically these 2 sections take up exactly half the flag, because the opposite of the other 2 sections. Explain why both students are correct. Well, Avery is just going to go ahead and take the area of the 2 striped rectangles and add them together, which would be correct. Whereas Pedro takes the whole area of the flag and divide by 2. And again, that makes sense because all of these rectangles are exactly the same. So if you take, they match up. This rectangle and this rectangle are the same, and then the two longer rectangles are the same. And if you just take half of those, that would be half the area of the flag. The perimeter of an equilateral triangle is 6x minus 6.3. So we need to know that the word equilateral is kind of like the word regular, as in all sides are equal. So I'll do my best to draw a triangle where all sides are equal. And we just know that the whole perimeter, if I add them all up, side 1, 2, and 3 is 6x minus 6.3. So if I take 6x minus 6.3 and I just divide everything by 3, I should get my expression. Well, 6x divided by 3 gives me 2x, and 6.3 divided by 3 gives me 2.1. So that means every side should be 2x minus 2.1, 2x minus 2.1, 2x minus 2.1. And if you don't believe me, let's add them all up. 2x plus 2x plus 2x, that gives us 6x. And negative 2.1 plus negative 2.1 plus negative 2.1, that gives us negative 6.3. So write an expression to represent the triangle's perimeter as the sum of its side lengths. Then write an expression to represent as product. Well, sum of its side lengths would simply be 2x minus 2.1 plus 2x minus 2.1 plus 2x minus 2.1. Done. And then the product would simply say, okay, if all three sides are equal, instead of just repeated adding them, I could take them and multiply by 3. 3 times 2x minus 2.1. And why might you want to represent the triangle's perimeters with one of the expressions we wrote in part B rather than the whole 6x minus 6.3? Well, that information from part B, right, one of the expressions we wrote in part B, gives us the side length, right? You might be in a situation where instead of wanting the whole perimeter of the shape, you just want the side length of the shape. Right? Please close your computer, do the exit tick, and move on to the next one.